Hello, grade 11 students. This time I will be discussing solving logarithmic equations or how to apply the different properties in solving logarithmic equations. Learning objectives. Number 1, recall the different properties of logarithm. Number 2, solve logarithmic equations. We have the following properties of logarithms. For x greater than 0, y greater than 0, a greater than 0, and a should not be equal to 1, and any real number r, we have the following rules or properties. Product rule, logarithm of xy to base a is equal to logarithm of x to base a plus logarithm of y to base a. So if you notice, the logarithm on the left is multiplication, xy, it's multiplication, and on the right, there is addition. So take note that the counterpart of multiplication is addition. From multiplication, you can change it to addition. Next, quotient rule, logarithm of x over y to base a is equal to logarithm of x to base a minus logarithm of y to base a. This time, this one is division and this is subtraction. So the counterpart of division is subtraction. Don't forget that. That's very important reminder to you. Next, power rule. Logarithm of x raised to r to base a is equal to r logarithm of x to base a. So what happened here? On the left side, r is our exponent. And then on the right side, r now is placed before logarithm. So meaning to say, from exponent, you have to bring it down before logarithm. So when you get the value of logarithm of x to base a, you have to multiply the result of this by the value of r or the exponent on the left. So don't forget these three properties of logarithms because these are very useful when you solve equations involving logarithms. Let's have the following examples. Assume all variables are positive. We write each expression using the properties of logarithm. All we have to do is to rewrite. We're not going to solve yet. Number 1, logarithm of 8x. If you notice, it's multiplication, so we have to apply addition. This is product rule, so the counterpart of multiplication is addition. This will become logarithm of 8 plus logarithm of x. As simple as that. Next, number 2, logarithm of square root of 8 to base 5. We cannot see any multiplication here, no division, but we can see square root, and square root can be changed to exponent. Please recall that square root of 8 is the same as 8 raised to 1/2. So therefore, we have exponent. So this is the same as logarithm of 8 raised to 1/2 to base 5. So this is power rule because we can see exponent, which is 1/2. And remember the rule that when you see exponent, you have to put this exponent before logarithm. So we have to bring down the exponent 1/2 before logarithm. So write logarithm and simply copy 8 to base 5. So this is the equivalent expression of logarithm of square root of 8 to base 5. Next, number 3, logarithm of 15 over 7 to base 9. So there is division here. The counterpart of division is subtraction. So this will become logarithm of 15 to base 9 minus logarithm of 7 to base 9. So that's all about these three examples, and we were able to apply all the three properties of logarithm. Let's have example number 4. This time, we really have to solve for x. So number 1, logarithm of x plus logarithm of 8 is equal to 2. We can see addition here, so we can apply product rule. This will become logarithm of x times 8 or 8x. Although x comes first, then 8, but when we write it together, number should come first. So 8 comes first before x equals 2. So what will happen next? We can now change this to exponential form. Simply copy 8x, and then we cannot see any base, so understood that there is 10 here. And then this 10, transpose it to the right, so this will become 10. Simply copy 2 as exponent. So remember, the number on the right of logarithm is always exponent. So this is the logarithm. Therefore, we can now solve divide by 8, divide by 8. So cancel 8. Then x is equal to 10 squared is 100. Simply copy 8. So x now is equal to 100 over 8. Then let's reduce the lowest term. Divide by 4. So 100 divided by 4 is 25. And 8 divided by 4 is 2. Therefore, our answer is 25 over 2, or if you want it to make it decimal, this is 12.5. So these are the accepted answers. It's either 25 over 2 or 12.5 in decimal. Example number 5, logarithm of x minus logarithm of 2 is equal to 1. So here we can see subtraction. The counterpart of subtraction is division. So we can apply quotient rule here. This will become logarithm of x over 2 is equal to 1. Simply copy x over 2 equals, so 10 here is our base. Then transpose it to the other side, to the right, and simply copy 1 as the exponent. Now, if it is 1, no need to write 1. So, x over 2 is equal to 10. This is now simple equation. We can now multiply both sides by 2 for us to get the value of x. So, this will become x is equal to, we can cancel this. 2 times x is 2x divided by 2 is 1x, this one. And then 2 times 10 is 20. Therefore, x is equal to 20. Let's see if 20 is really the value of x. Let's check. Going back to the original given, logarithm of x minus logarithm of 2 is equal to 1. So let's replace x here with 20. So this will be logarithm of 20 minus logarithm of 2 is equal to 1. So let's solve it. Using calculator, logarithm of 20 minus logarithm of 2 is really equal to 1. So 1 is equal to 1. Therefore, our answer 20 is correct. Example number 6, logarithm of negative 2a plus 9 equals logarithm of 7 minus 4a. We can see addition here, but we cannot apply product rule here since both negative 2a and 9 are inside the parentheses. We can only apply the property if we have also logarithm before 9. So here also there is minus, but we cannot apply quotient rule because 7 minus 4a is considered together for logarithm here. Unless there is logarithm before 4a, then we can apply quotient rule. So we have to do something. Instead of applying those rules, we have to create another equation out of this that we can apply any of the three properties. So in this case, when you see like this, you have to transpose this to the left. So this will become logarithm of negative 2a plus 9 minus logarithm of 7 minus 4a. is equal to 0. Now, we have subtraction, so we can now apply quotient rule. So this will be logarithm of, this will be our numerator, negative 2a plus 9 all over, this one is next, 7 minus 4a is equal to 0. So what's next? We can now change this to exponential form. So there, understood that there is 10 here, and then transpose it to the right, this will become 10 raised to 0. 10 raised to 0. And then this one, simply copy here. So negative 2a plus 9 all over 7 minus 4a is equal to 10 raised to 0. Take note that 10 raised to 0 is equal to 1. So what will happen now? Before I continue, let me erase first so that I have space here for me to show you the continuation. Okay. So let me now continue this. So we're here, then let me continue. Negative 2a plus 9 all over 7 minus 4a is equal to 1. So take note, 10 raised to 0 is equal to 1. Next, we have to simplify this now. We have to look for the value of a. When you see denominator here, multiply both sides by 7 minus 4a. It's the denominator here. Multiplying 7 minus 4a, we can cancel this and this one. So negative 2a plus 9 will remain, equals, multiply 7 minus 4a by 1 here, then it will become 7 minus 4a. And then let's simplify this. Negative 2a, transpose negative 4a to the right, this will become negative 2a plus 4a equals 7, transpose 9 to the right, then we'll have negative 9. So 7 minus 9. So this is now negative 2a plus 4a is 2a equals 7 minus 9 is negative 2. Then divide both sides by 2. Cancel 2. A is equal to negative 1. The value of a is negative 1. If you want to check or to verify whether negative 1 is correct, then you can do the checking later. Simply replace your a here with 1 and another a here with 1. And see to it that both sides will equate to the same number. Example number 7, solve for x. Logarithm of 2 to base 8 plus logarithm of 4x squared to base 8 is equal to 1. We can see addition here, therefore we can apply product rule. This will become logarithm of 2 times 4x squared to base 8. Simply copy base 8 is equal to 1. And then we can now transpose 8 to the right and make 1 as its exponent, but then if it is 1, no need to write 1. And then simply copy this part, distribute 2, so 2 times 4 is 8, copy x squared. Divide both sides by 8, cancel, x squared is equal to 1, and then simplify, get the square root of x squared equals square root of 1. X squared, square root of x squared is x, square root of 1 is positive, negative 1. So the values of x are positive 1 and negative 1. Let's have example number 8. 10 logarithm of 6x equals negative 10. Or another way of reading this is 10 times logarithm of 6x is equal to negative 10. If you see number before logarithm, you transfer it as the exponent of whatever number you have here. So this will become logarithm of 6x raised to 10 is equal to negative 10. Next, understood that we have 10 here, so simply copy 6x to the 10th power is equal to 10 raised to negative 10. So 10, this 10 came from here, and this one becomes the exponent. Next, let's simplify this. We have 6x raised to 10 equals 10 raised to negative 10. So let's continue simplifying this. This is the same as, let's copy first, 6x to the 10th power is equal to, since we have negative exponent here, let's get the reciprocal of 10. 10 will become 1 over 10. Our goal is to make the exponent negative here positive. So here, this will become 1 over 10 raised to 10. Then continue, 6x raised to 10 is equal to 1/10 raised to 10 will become 6x. Let's copy first. 6x raised to 10 is equal to 1 over 10 raised to 10. When you see exponent, our goal is to isolate x. So let's get the 10th root. Let's get the 10th root of both sides. 10th root. Then we can cancel 10 here in this radical sign. So that 6x will be outside. Equals, this will be cancelled also, or the 10th root of 1 is 1, and the 10th root up to the 10th power, 10th root of 10 to the 10th is simply 10. Then, let's multiply both sides by 10. This will become 10 times 6x is 60x equals 10 times 1 over 10. 10 times 1 over 10 is 1. Divide both sides by 60. Cancel 60. X therefore is 1 over 60. So this is the final answer, 1 over 60. So let's check if our answer is correct, whether 1 over 60 is the correct value of x to this equation. Let me erase my solutions here so that we can see clearly the given. Then we can replace x with 1 over 60. Okay. So copy 10, copy logarithm, copy 6, replace x with 1 over 60 equals negative 10. We have to expect that all of this will become negative 10 so that it's equal to the number on the right, which is also negative 10. 10 logarithm of 6 times 1 over 60 is 1/10, right? So 6 times 1 over 60, take note, 6 over 60, because 6 times 1 is 6, and simply copy 60 below. Reduce it to lowest term, it's 1 over 10. So, this part is 1 over 10, then equals negative 10. Now, it's either you press your calculator, logarithm of 1 over 10, and then multiply by 10. And set to it, you will get negative 10. Or if you don't have calculator, applying the property of logarithm, it's the same as 1 over 10 raised to 10. So logarithm of 1 over 10 raised to 10 is equal to negative 10. So take note that logarithm of 1 over 10, when you get the reciprocal, it will become 10 raised to negative 10 raised to negative 10. And when you get the logarithm of 10 raised to negative 10, it's the same as negative 10. So therefore, negative 10 is equal to negative 10. So 1 over 60, 1 over 60 here is really the correct answer. Number 9 example, logarithm of 5x is equal to logarithm of 2x plus 9. We have to transpose this part to the left so that we can have subtraction. So this will be logarithm of 5x minus logarithm of 2x plus 9 is equal to 0. Next, since we have now subtraction, we can now apply quotient rule. So this will be the same as logarithm of 5x over 2x plus 9 is equal to 0. Now, understood that our base here is 10, we can now transpose 10 to the right with the exponent 0. So 10 raised to 0. And then simply copy this part, 5x over 2x plus 9. Let's simplify this further. Copy first 5x over 2x plus 9 equals 10 raised to 0 is 1. Multiply both sides by 2x plus 9. 2x plus 9. Then this will be cancelled. Copy 5x equals 2x plus 9 times 1 is 2x plus 9. Then transpose 2x to the left. This will become 5x minus 2x equals retain 9. 5x minus 2x is 3x equals 9. Divide both sides by 3. Cancel 3. X is equal to 3. That's all for now. Thank you for listening and watching to my presentation. Thank you and God bless us all.